Has graphing got you grumpy? Are you sick of substitution? You're not alone. Studies show that 173% of adults and 4 million% of children, just like you, gaze longingly at systems of equations, desperate for another way. Well, despair no longer, because clinical trials show that the combination/elimination method for solving systems is here to clear your skin, brighten your mood, and ease the weight of the burden of your existence. Ask your doctor if combination/elimination is right for you. Side effects may include expanded brain power, improved self-confidence, appetite for further knowledge, and spontaneous combustion. Do not use combination/elimination while operating heavy machinery. Hi friends, how are you? Fifth class of Unit 5. Today we're going to talk about our second method for solving systems of equations algebraically. Its name is combination or elimination. The two names are interchangeable. And this is part 1. So, we know that graphing is one way to find the point of intersection for our lines. Another way algebraically that we've talked about is substitution, where the idea is to get something by itself in one equation that I can plug in to the other equation in my system and use that to find the values of my variables. For combination or elimination, interchangeable names, I'm actually, in a rare turn of events, going to show you how it works first. And once we've got that idea down, we'll figure out why it works and what's actually going on. So the idea behind combination or elimination is actually in the name. In order to perform this strategy, what I am trying to do big picture is find some way to combine two of the equations in the system in order to eliminate one of the variables in the system. Now, if I'm trying to combine two things in math, usually that tells me I'm using a particular operation. What do we usually use to combine things in math? Go, 10 seconds. 5, 4, 3, 2, 1. Well, if I want to do some combination of things, usually what that tells me is I'm trying to add them together. For the purposes of this, though, addition is the same thing as subtraction, right? Subtraction is just fancy addition. So what I'm trying to do using combination and elimination is to either add the equations in the system together or subtract one of them from the other. Let's see how it works. So there's the idea. I want to add or subtract my two equations. Look at this set. M plus 5n equals 18 and n minus m equals 0. What's interesting here is that m and negative m, those are opposites of each other. And we should know that if I add opposites together, they will undo each other. So by this strategy, let's see what happens if I add the top equation and the bottom equation together. Well, on top, notice I've got m plus negative m. M plus negative m, those are going to go away. They're going to undo each other. Adding down 5n plus n, combining our like terms, that's 6n. And then 18 plus 0 on the right side of the equal sign is 18. And from here, if I want to solve for n, well, the only thing left for me to do is divide by 6. Dividing both sides by 6 shows me that n is equal to 3. And from here, now that I have a value of n, all I need to do is use it to find the value of m. So I'm going to take this guy. Let's use the bottom equation. Why not? I'm going to substitute in, just like with substitution, once I find my first value of the variable, to find the second one. So over here, I know that n minus m is equal to 0. By substitution, n is equal to 3. So that tells me that 3 minus m is equal to 0. I want to get m by itself, so why don't I just add m to both sides here? That tells me that 3 is equal to m. Cool! By the way, as an ordered pair, how would I write this? 5, 4, 3, 2, 1. Very nice. Well, m comes before n in the alphabet, so as an ordered pair, again, this is optional. I don't need to do this step, but here is my ordered pair notation for my system's solution. Okay, so this is what I'm doing, but why am I able to do it? What's actually going on here? What do you think allows me to make this choice? Why can I add or subtract two equations from each other? 30 seconds, look back at your notes. I would say unit 0 might be a good place to look if you want a suggestion. Why can I make this choice? Why is this mathematically okay? Go. And stop. So, big picture. Notice, if I'm adding these two equations, the fact that there is an equal sign in the middle tells me that the left side and the right side are the same. What I'm really doing here is adding the same thing to both sides. N minus m and 0 are the same thing we've established. What I'm really using here, this is just an example, a more complicated example, but an example nonetheless, of what we called back in unit 0, the addition property of equality. I can add or subtract, if I want to, the same thing from both sides, and I will still maintain the equality of my equation. Cool! So we know that combination and elimination is really just an extension of the addition property of equality. And now that we know why it works, and now that we know how it works, let's get some practice using it. Cool! Take this guy. Y equals negative x plus 5, y equals 2x minus 1. I want to use combination or elimination, whichever you prefer, to find the values of x and y. Go ahead, try it out on your own, see how far you get. Take 2 minutes. Have at it. And stop. So, strategically, my goal is to eliminate one of my variables. Between these two, notice I have a y and a y. That's probably the variable that I want to eliminate. So I either want to add the two equations together or subtract the two equations. Y plus y wouldn't get rid of y. So if I'm thinking strategically, I probably want to subtract the bottom equation from the top. So on the left side, y minus y is equal to 0. On the right side, I have negative x minus 2x. Negative x minus 2x is negative 3x. And then finally, I have 5 minus negative 1. 5 minus negative 1 is 5 plus 1. So 5 minus negative 1 is equal to positive 6. From here, again, I just need to solve for x. Well, I'll start by subtracting 6 from both sides. I could add 3x to both sides. It doesn't matter. Negative 6 is equal to negative 3x. Divide both sides by negative 3, and that tells me that x is equal to 2. That shouldn't surprise us if you look back at your notes from 5.3, I think, and also 5.2. We've solved this system before. Now I know that x equals 2. Let's find the value of y. So I'm going to choose the bottom equation. Again, it doesn't matter. I could use the one on top too. So I know that y is equal to 2x minus 1. We've said that x is equal to 2. So I'm going to replace x with 2 using substitution. From here, I know that y is equal to 4 minus 1, which means y is equal to 3. Cool. As an ordered pair, how would I write this? 5, 4, 3, 2, 1. Well, x comes before y in the alphabet, therefore 2 comes before 3 in our ordered pair. Nice! And on we press. Next one. 3d equals 18c minus 33. Negative 2c minus 3d equals negative 7. I want to use elimination in order to find either, using addition or subtraction, whether I can get rid of one of my variables. Which one's probably going to go away? And then once you've got to that place, let's find the values of our variables. 2 minutes. Pause the video. Have fun. Go, go, go. All right. So if I'm thinking about which variable is going to go away, I've got a 3d here. I've got a negative 3d here. These guys are the same. I want to find a way to get rid of them. 3D and negative 3D. Would addition or subtraction get these to cancel each other out? Well, if I have a positive and a negative, I want to add these two together. Cool. So adding down on the left side, right, I have 3D minus 3D. These guys are going to go away. So I'm left with 0 on the left side, and then I have that negative 2c there. Let me just carry that down. On the right side, I have 18c plus there's no c's on the right side of the bottom equation, so I'm just going to carry down my 18c. And then I've got negative 33 plus negative 7. Well, that is equal to negative 40. Cool. And from here, all I need to do is get c by itself. This is also, by the way, a system of equations that we've solved already, so we should know its solution, but let's find it again. Negative 2c minus 18c, well, that's negative 20c is equal to negative 40. Dividing both sides by negative 20, that shows us that c is equal to 2. Once again, I'm going to take my value of c and substitute it into one of my two equations. Here I'm going to pick the one on top, but it doesn't really matter. So I know that 3d is equal to 18c. c is equal to 2. So we're going to use substitution there to replace our c with a 2. 3d is equal to 18 times 2, which is 36, minus 33. 36 minus 33 is positive 3. Divide both sides of our equation by 3 to find that d equals 1. As an ordered pair, how would I write this? 5, 4, 3, 2, 1. Well, c comes before d in the alphabet, therefore 2 is going to come before 1 in our ordered pair notation. Fantastic! Let's do 2 more. Next up, 4k plus 2j equals negative 28. 2j minus 3k equals 21. What looks like it's cancel-outable? Which operation, addition or subtraction, are you going to use? Go ahead, find k and j. Okay, so here I see a 2j and a 2j. That's probably what I want to cancel out. I have a positive 2j and a positive 2j. If I want to get those to undo each other, let's use subtraction. So I'm going to subtract my bottom equation from the top equation. So I've got 4k minus negative 3k. Minus negative 3k would be plus 3k. So 4k plus 3k is 7k. 2j minus 2j, well, these are going to undo each other. That's 0. And then I've got negative 28 minus 21. That's negative 49. All I need to do to get k by itself is divide both sides by 7. That tells me that k is equal to negative 7. Now that I know k is equal to negative 7, let's pick one of our two equations to plug back into. I'm going to choose the one on the bottom because it has smaller numbers. But you can use whichever you want. So I know 2j minus 3k, but k is equal to negative 7 is equal to 21. From here, I just need to solve for j. So I have 2j. Negative 3 times negative 7 is positive 21. And then I know that's equal to 21. To get j by itself, I'm going to start by subtracting 21 from both sides, which shows me that 2j is equal to 0. Dividing both sides by 2 tells me that j is equal to 0. K is negative 7, j is 0. As an ordered pair, how would I write this? 5, 4, 3, 2, 1. Well, j comes before k in the alphabet. Just kidding. So 0, comma, negative 7 is our ordered pair. Very nice. Last one, best one. Let's take this guy. 3v minus 9u equals 9. u plus 3v equals negative 6. What am I going to cancel out, and which operation am I probably going to want to use? Go ahead. Alrighty, let's do it. So notice I've got 3v here on top, 3v here on the bottom. If I want to undo a positive 3v and a positive 3v, right, I probably want to subtract 3v from 3v. So I'm going to use subtraction here. Using subtraction, right, 3v minus 3v, that's 0. I've got negative 9u minus u. That's going to be negative 10u. And then that's going to be equal to 9 minus negative 6. 9 minus negative 6 means 9 plus 6, which is 15. All I've got to do to get u by itself is divide both sides by negative 10. So that means that u is going to be equal to 15 over negative 10. Both of these have a common factor of 5. If I cancel out that 5, that leaves me with negative 3 over 2. Knowing that u is equal to negative 3 over 2, I'm going to substitute back in to one of my two equations. Let's choose the one on the bottom. Again, it does not matter. So u, which we know is negative 3 over 2, plus 3v is equal to negative 6. I want to get the v by itself, so let's start by adding 3 halves to both sides. On the left side, that's just going to leave me with 3v. And then off to the side, right, I need to do negative 6 plus 3 halves. If I want to combine something with a fraction, I need a common denominator. So I need to rewrite 6 as some fraction of 2. Negative 6 would be the same as negative 12 over 2. Adding these together, negative 12 plus 3 would be negative 9 over 2. So the right side of my equation is negative 9 over 2. All I've got to do now is divide by 3. So I've got negative 9 over 2 divided by 3. Again, Kentucky Chicken Fried, keep, change, flip. I'm going to multiply by the reciprocal of 3, which is 1/3. Notice here that 9 and 3 both have a common factor of 3. Canceling these out, I get negative 3 halves times 1 over 1. Well, that is just negative 3 halves. Kind of trivial here, but how would I write this as an ordered pair? 5, 4, 3, 2, 1. In this case, the order doesn't matter because we have the same number either way. But technically, u comes before v in the alphabet, so u equals negative 3 halves would come first, followed by v equals negative 3 halves in the second slot. Fantastic! You now know not all of how to solve by combination and elimination, but the gist of it. Congratulations, I'll see you next time. We'll wrap up our discussion in Unit 5.6. Goodbye!